Welcome back. In our last lesson, we solved equations containing radicals where we had one possible solution. In today's lesson, we're going to look at equations containing radicals with more than one possible solution. We're going to use the exact same steps, though, that we used yesterday. And remember, while watching these videos, you should pause them to copy down notes that you want to keep in your notebook, or to try a question before I solve it for you. Here's our first example. We're going to solve a cube root equation. Now, if you look at this, you might not recognize it as a cube root, but you have to recall that exponents can be written as fractions. When an exponent is a fraction, the denominator tells us the root that we're taking. So in this case, it's a third root or cube root. We could write an equivalent equation this way, by removing the fraction but using the radical sign. The numerator of the fraction would tell us the power we are raising it to. So here we're raising it to the first power but taking the third root. Like yesterday, we want to get rid of the 1/3, the exponent here, or cube root. So we have to isolate it and then raise each side of the equation to the third power. In order to isolate the radical, we have to subtract 5 from each side. Now, if you recall yesterday, I said when we have the square root, it's never going to come out as negative, because if we square a number, whether the number is positive or negative, it's always going to be positive. 2 squared is 4, negative 2 squared is also 4. That's not the case when we have odd powers. So here, we are going to cube each side, and now since it's negative 5 to the third power, negative 5 to the third power is going to be negative 125. We evaluate the cubes. When we multiply the 1/3 times the 3, we would get 3 over 3, which becomes 1. So now the exponent is eliminated. We got rid of the radical, just like we were doing in yesterday's exercises. We can evaluate the cubes and now solve the equation that remains. Here, I subtracted 1 from both sides, divide each side by 3, and our solution is y equals negative 42. We're going to check the solution in the original equation by substituting negative 42 in for y. We're going to evaluate first what's inside the grouping symbol. So I'm going to do the 3 times the negative 142 and then add 1 to it. Now I'm going to take the third root of negative 125 and then see when we add 5 to it if it gives us 0. Well, we saw that negative 5 to the third power is 125, so the third root or cube root of negative 125 is negative 5. So this solution checks. So our solution is y equals negative 42. Now we're looking at solving another square root equation. Here, we have a trinomial underneath the radical as our radicand. But the steps are still going to be the same. We want to isolate the radical term, which in this case it's already isolated. So we square both sides of the equation. When I square the square root of x squared minus 3x plus 3, the square root and the squared undo each other and cancel each other out. So we're left with x squared minus 3x plus 3 equals 1 squared, or 1. Anytime you have a quadratic, you want to try and set it equal to 0 so that you can factor and use the zero product property. So in this example, we need to subtract 1 from both sides of the equation so that the right side of the equation is 0. Now we can factor x squared minus 3x plus 2 by looking for the factors of 2 that are going to add to give us negative 3. Well, since 2 is prime, its only factors are 1 and 2. Since we need them to add together to give us negative 3, the factors must be -2, and -1. Using the zero product property, we can set each factor equal to 0 and solve for x. So here we have x equals 2 and x equals 1. We're going to check both solutions. So we take the original equation, we substitute in the values that we found. So over here I'm going to check 2, and over here I'm going to check 1. So when we simplify, 2 squared is 4, -3 times 2 is -6. And we see that we have the square root of 1. 4 minus 6 plus 3 gives us 1. And the square root of 1 is 1. So 2 is a solution. We're going to do the same thing over here for 1. And when I check, the square root of 1 equals 1. So both 2 and 1 are solutions to this equation. So here we ended up with 2 solutions, and both solutions checked. We can look at one more example. Here I have the square root of 17 minus 2a is equal to a minus 9. So, looking at this example, our radical term is isolated on the left side of the equation, but on the right side of the equation we have a binomial. So we're going to have to be careful when we square both sides of this equation. So here when we square, the square root will cancel out by the squared. And now we have to square the quantity of a minus 9. Remember, that means we need to multiply the quantity of a minus 9 by itself. So here we're going to use the distributive property to multiply the quantity of a minus 9 times the quantity of a minus 9. So we get a times a is a squared, a times -9 is -9a, -9 times a is -9a, and -9 times -9 is positive 81. We can combine like terms on the right side of the equation. So here we have our -9a and -9a becomes -18a. This is a quadratic function, so we're going to want one side of the equation to be set equal to 0. It's best if you have the squared term positive, so we're going to move both of these terms over to the right side of the equation. So I'm going to add 2a to both sides of the equation, and then I'm going to subtract 17 from both sides of the equation. So we now have a squared minus 16x plus 64 is set equal to 0, so we can factor this trinomial. I'll be looking for the factors of 64, that when I add them together, they give me -16. It's going to be -8 and -8. We call this a double root because this now is a perfect square trinomial because it's the quantity of a minus 8 squared. Just like up here we had a minus 9 squared. And this is a perfect square trinomial. So when we use the zero product property, since the factors are the same, we end up with one solution, a equals positive 8. So now I'm going to check my answer by substituting in 8 into the original equation. I'm going to simplify under the radical. 2 times 8 is 16. 17 minus 16 is 1. But is the square root of 1 equal to -1? It is not. So here we're going to have no solution. The equation does not check. There is no real solution. So that's the additional examples for today's lesson. Again, here are the steps. So if you didn't have them, you could take a minute and write them down. You should be going every day online and doing the check-in for your participation points. We'll be collecting your attendance as you check into each one of your classes each day, so I'll have a brief activity for you to complete. Today's activity is vocabulary, which some of you already started doing because I posted it a little early. You also have a classwork activity on Delta Math. You'll see it as Solving Radical Equations, Lesson 2. If you have any questions, I'm just an email away. Stay safe.